Do you want to excel in maths and science? If your answer is yes, then let me tell you, go ahead with Infinity Learn courses. And to get best discounts, subscribe right now. The link is given below in the description. Hello everyone, welcome to my channel. And as you all know that my channel is in now collaboration with Infinity Learn. So now you're going to get much more quality content. So today I have taken a topic from science. Obviously, I'm your science expert, so I've taken topic from science, particularly from chemistry, and we will be discussing the topic which is from chemical bonding. So before I get started, I would really like to share with my students that to avail extra 10% discount, what you can use is, you can use the coupon code DE10. So if you'll use it, you'll get extra 10% discount. So avail the discount. Okay. So before we go ahead, I want to ask you this, that can you identify the difference between two? Can you tell me what exactly you can, see in two pictures? You can just pause the video right here, think for the difference, write in your notebook, unpause it, and then match your answer. Okay. So let me tell you that this first picture represents oxygen atom. It represents oxygen atom. Right? And this second picture represents oxygen molecule. Why molecule? Because here you can see that two oxygen atoms, they are linked together. They are linked together. And how, you can see the linkage. See, this is the linkage. This is the linkage which is holding, the oxygen atoms together in a molecule. Right? So this is the difference between these two pictures. Now let me tell you that if particularly we talk about molecule, so molecule is formed when two or more atoms combine together. Like in the previous example we saw, and we stated this as a molecule because in this you can see that two atoms of oxygen, they are just combined together, right? And how they are combined? They are linked together basically by a chemical bond. So this is a molecule. Right? So it's not necessary that every time a molecule will have two atoms. It may have more than two. For example, sulfur exists as S8. That means eight atoms together form one sulfur molecule. Similarly, phosphorus exists as P4. Four atoms of phosphorus combine to form one molecule of phosphorus. So atoms can be, two or more in number. Now talking about that how they are linked. Right? So before we proceed that how they are linked, I want you to identify A in this picture. This is A and you have to tell me that what do you think is this A? Now let me tell you, like if I consider this big ball, this as a big ball and these as a small balls, then you can see that these balls are linked together with a big ball with something, right? So this something is nothing but a linkage. And in chemistry, we call the linkage as a chemical bond. We call the linkage as a chemical bond. So let's study about chemical bond. So how will you define the chemical bond? Chemical bond is basically the linkage between two or more atoms to form a molecule. Like we saw that two oxygen, they are linked together and they are linked together by a chemical bond. So chemical bond is a linkage which holds two or more atoms together in a molecule. So whenever, more than one atom is present or in a molecule, more than one atom, they join. How they join? They get linked by a chemical bond. Right? And you know that what is the reason behind the linkage? Why they are linking? Why they don't exist just as O? Why oxygen exists as O2? The reason is that everything in universe needs to be stable. Everything in universe is looking for the stability. And if you will consider just oxygen atom, you know that the atomic number is 8 and configuration is 2,6. So you will see that it doesn't obey the octet rule because it is not having 8 electrons in its outermost shell. So in order to be stable, so what it does, it combines with other oxygen, right, and attains stability because it completes the octet. Both the oxygen complete their octet. Now how they complete, how they attain stability, don't worry, I'm going to explain it just in this video. Okay, so let me tell you, you have to remember this, that chemical bond, why it is necessary. Chemical bond is necessary, or the atoms, they get linked with other atoms to attain stability. Stability, the maximum is the stability, minimum is the energy. Right? So minimum energy state always corresponds to maximum stability. Right? So we have two kinds of chemical bond. One is ionic bond, and the other chemical bond, I'll write here. One type of bond that I'll be discussing is ionic, and the other bond is covalent bond. Now talking about ionic bond, it is formed by transfer of electrons. It is formed by transfer of electrons, and it is always formed between a metal and a non-metal. Let me give you one example. If somebody asks you that what kind of bond will exist between sodium and chlorine, so how will you show the bond formation, or how you come to know that what kind of bond would be there? So first thing, you have to write their atomic numbers. After writing, you have to write their configuration. Right? Now, you know that all the elements which have 1, 2 or 3 in their valence shell, they are metals. And all those which have 5, 6, 7, they are non-metals. So metal and a non-metal is combining. So obviously the bond is going to be ionic. So how will you represent it? You will show sodium, right? It has 1 electron. So in order to be stable, it will lose its 1 electron. And after losing, it form Na positive, right? And the configuration would be 2,8. Same way chlorine, it has 7 valence electrons. So you will represent this way, right? So it will take 1 electron to complete its octet, and after taking, it will be Cl negative, because electrons would be more in number as compared to protons by 1. That is the reason it has a quite negative charge. So overall bond formation can be summed up: Na with 1 electron, chlorine with 7 electrons. And what they are forming? This Na positive, Cl negative. You crisscross their valencies and you get the molecule as NaCl. So this is the way to represent ionic bond. And how will you come to know that which bond will exist in different elements? If you have a combination where a metal is combining with non-metal, then always the bond formation will be ionic bond. You need to remember this. Now another type of bond, ionic, we have already discussed. Right? We have already discussed the ionic bond. Now let's discuss about the covalent bond. So covalent bond is the bond which is formed by mutual sharing of electrons. It is just like if you have one toffee with you and one candy and you wish to share with your friend. So what do? You can just half it and you all both can share. So it is similar to the sharing of the candy with your friend. So it is mutual sharing of electrons, and this bond is always formed between a non-metal and a non-metal, always. Okay, let me give you one example. For example, oxygen exists as oxygen molecule, that is O2O combined to form one O2. So oxygen, the atomic number is 8, configuration is 2,6, configuration is 2,6. Okay, now you know that it is not stable because both of them needs 2 electrons to attain stability. So what we'll do is we will represent one oxygen and we will arrange these 6 valence electrons in such a way that the number of electrons that it needs is always put in the center, put towards the other atom. So 2, 4 and 6. This is how you will arrange. Same way in another oxygen you will arrange in this way. 6, 6. Now how many they need? They need 2. That is the reason I have put 2 in the center. So for this oxygen, 6 it already has and 2 it will share from the neighboring one. Same way 6 this oxygen already has and 2 it will share from the other one. So how many mutual shared pair? See, 2. So this is a covalent bond, and after forming bond you can see that both of them, they have 8 electrons now in the outermost shell. So this is how the covalent bond is formed, and you need to remember that it is always formed between a non-metal and a non-metal. Okay, so this is how you make out that which bond will exist between any two given elements. Okay, another question to you. Identify the difference between the bonds shown. So here in first picture, you can just pause the video and think for the answer and then unpause and match your answer, okay? I always give you time to think over because I always want that when you proceed with me further, I want you to involve totally in the lecture, okay? So the difference between the bonds shown between three pictures, let me tell you, these are two hydrogens, right? And they are linked by a bond, and this you can see is a single bond. Two oxygen linked together by a double bond. Two nitrogen, you can see three linkage, linked together by triple covalent bond. I'll write here triple, and this is double covalent bond, and this is single covalent bond. You must be thinking that why I have directly written covalent bond. This is because all of them are non-metals. In this case also two non-metals are combining. Here also two non-metals. Here also two non-metals. And I told you that whenever two non-metals are combining, they always show covalent bond formation. They do mutual sharing of electrons. But the difference here is that two hydrogens are linked by single covalent bond. Oxygen is linked by double covalent bond, and nitrogen, two nitrogen, they are linked by triple covalent bond. Now, what do we mean by single, double and triple? Let's make out the difference. So, single covalent bond is that in which there is only one shared pair of electrons. Only one shared pair. Means one electron is contributed by one hydrogen, one by other, and they are sharing one electron. Let me give you example. Hydrogen. You know that in hydrogen, the atomic number is 1 and even the configuration is 1. And for hydrogen, it is duplet rule. That is tendency to have two electrons in its first shell. Now, we can show this one electron as this. We can show this one electron as this. So, this hydrogen has its 1 and it will share the 1 from the other. Same way, this hydrogen will do. So, how many electrons they have shared? There is only one shared pair. So, that is the reason it has one shared pair, one single bond. So, that is why you say that it has a single covalent bond. This is how you have to make it. Okay. Now, moving on to double covalent bond. So, simply it will be having two shared pair of electrons. This we have already discussed. Still, I'll make it for you. We know that oxygen, it has 6 electrons, it needs 2. So that is the reason I'm putting 2 in the center towards the neighboring one. So 6 and 2 it will share so that it attains octet. Same way 6 and 2 it shares to attain octet. So how many electron pairs? 2. So it will be shown like this as shown in the picture. So now here we have 2 shared pairs. So that is why the bond is said to be double covalent bond. Same way, triple covalent bond which has 3 shared pair. Let me make it for nitrogen. See, nitrogen, 2 nitrogens are combining. Atomic number is 7. You will write the configuration, right? And both of them needs 3 electrons. So, you will put 3 in the center. Whatever they need, you have to put facing towards the neighboring, okay? And 2 this side. Then this 5 and 3 becomes 8. This 5 and 3 becomes 8. How many shared pair? 3. So that is the reason it has got triple covalent bond. This is how you have to, show the bond formation in the molecules. Okay, another question for you. Can you guess the name of the molecules and the types of bonds in given molecules? Hint I am giving you. You can just count, the bonds. Then you can tell single, covalent, double. Also, you can see the formulas. You can make the formulas and tell me the name of the molecules if you know. And also, it is asked that the type of bonds, that is ionic or covalent. That you know, that if the combining atoms are metal and non-metal, it is ionic. If two non-metals, then it is covalent. So, take time, pause the video right here and write it down and then match your answer with my answer. Okay, let me tell you, this first one is, I'll total it, NH3. NH3 is nothing but ammonia. And this is H2O, which means water. And this is C, 1C and 4H, that is methane. So, these all molecules, you can state their names, ammonia, water and methane. Now, what kind of bond? See, it's a non-metal, it's a non-metal. You'll write the atomic number, write the configuration, look for the valence electrons. You will come to know that whether it is metal or a non-metal. Okay. Same way, this bond is also a covalent and even this is a covalent because all the combining ones are non-metals. Now, how these bonds are formed, let's discuss about it. Okay, let's show the covalent bond formation in ammonia. So we have one nitrogen and three hydrogen, right? So what we'll do is we'll write the atomic number first, configuration, right? It needs 3 electrons. Now you have NH3, so the central atom would be N. You will place N and 3 hydrogens will be surrounding nitrogen in this way. All the hydrogens, they have 1 electron, so you will put it, whether you use dot to represent or you may use cross, okay? So to distinguish between the electrons, I am using cross for nitrogen, okay? So it's 5. So nitrogen has to forcefully put its 3 electrons facing 3 hydrogen and left 2 ones can be put here. Now this hydrogen shares this electron, becomes stable, even this and even this. All the hydrogens, they have attained duplet now. This nitrogen already have 5 of its own. 3 it will share from each hydrogen, and this is how the bond will be formed. So how many shared pairs? See, 1, 2 and 3. And these 2 electrons doesn't participate in the bond formation. And let me tell you, those electrons which doesn't participate in the bond formation, they are called as lone pairs. What we call them as? We call them as lone pairs. And the electrons which participate in the bond formation, we call them as bond pairs. Okay? So it has got 3 bond pairs and 1 lone pair. So you can represent it like this, or even you can represent it with this kind of cloud. So I hope it is clear. So it is having single covalent bond. Like all the 3 bonds are single, so you say it is having single covalent bond. But if somebody asks you how many covalent bond, you can see. So you'll say the number of covalent bonds are 3, but all of them are single. Okay, let's talk about water now. So we have 2 combining atoms, oxygen, hydrogen. Oxygen atomic number 8, configuration this. Hydrogen is 1, configuration is 1. So central atom, obviously we have H2O. So central atom is oxygen. We will arrange the hydrogen in such a way. See, always the atoms are arranged around the central atom in such a way to minimize the repulsions. Okay. Now, how the repulsions are reduced or how the arrangement occurred, we'll be discussing in another video where we'll be discussing the bond formation theories. Okay. So for now you can just make it this way. So hydrogen is having 1 electron and even this hydrogen is having 1. Oxygen has 6. So it has to put 1 facing each hydrogen because hydrogen needs only 1. So oxygen has to put only 1 facing each hydrogen, and left 4 can be represented like this. So this hydrogen becomes stable because they attain octet, and this oxygen 2 and 4, 5, 6 and 7, 8. So this is how you can represent. So that means single bond with both the hydrogen and 2 lone pairs. So we can represent the lone pairs. I hope you remember lone pairs that doesn't participate in bond formation. So we can make the electron cloud like this also, or you can skip it making, or you can make the electron cloud as I have made. Okay, another one, methane. So combining atoms are carbon and hydrogen. So carbon atomic number 6, configuration 2,4. Hydrogen 1, configuration 1. So central atom would be carbon. So I am putting carbon and I am arranging hydrogen like this around carbon. So all the hydrogen, they have 1 electron and carbon has 4. So carbon will be distributing each electron facing each hydrogen. So this hydrogen will be stable, this hydrogen will complete or duplicate, this will be stable, and even this will. And carbon has its own 4 and it will share 4 from other bonded hydrogen. So it has formed again a single bond, but how many covalent bonds? 4 bonds, because 4 hydrogens are combined here. So this is how you can show the formation of methane. So it has no lone pairs because all the 4 electrons are participating in the bond formation. So with this, we have come to an end. I hope you have understood the concept. So my suggestion is to you is please practice it again and again, because more you practice, more you will be proficient. And one thing more, students, that if you haven't subscribed my channel, then subscribe it right now, because this is the channel where you're going to get the quality content. So thank you, take care and keep supporting me. Thank you.